Hello and welcome back to Math 103, College Algebra. Today we're going to look at section 2.1, which is equations of lines. Writing the equation of a line, I'm going to use three forms. You notice here I'm going to start by looking at point-slope form of the equation of a line. We're going to look at slope-intercept form of the equation of the line, and we're going to look at standard form of the equation of a line. It's my understanding, my impression that in many algebra classes, we spend some time with equations in standard form, and we spend a lot of time talking about equations in slope-intercept form. Something that does not get covered as much is point-slope form. I'm going to talk about point-slope form first, primarily because I think it's easier. In a lot of cases, I think it's better. And especially in a college course, I encourage students to use point-slope form more frequently than either slope-intercept or standard form, and we'll come across that in a little bit. So let's look at point-slope and what we mean by the point-slope form here. Consider we have slope is y2 minus y1 over x2 minus x1. And this is the slope formula that we're all often given, or we're used to using. I'm going to make two adjustments. First of all, we don't know two values of x and y, right? We're just going to use one of them. We'll need two eventually. We'll use one of them. If I only know 1 point, x1, y1, another adjustment I'm going to make is I'm going to, instead of writing this m equals y minus y1 over x minus x1, I reverse the order here. And I have the difference of the y's over the difference of the x's equals the slope. If now I multiply both sides of this equation by x minus x1 divided by x minus x1 will cancel out, and they'll divide out to equal 1. And now we have y minus y1 equals m times x minus x1, where m is still the slope, but we have this form of the point-slope form of the equation. Some people will choose to add y1 to both sides, so they have the equation solved for y equals m x minus x1 plus y1, and that gives us this alternative form of the point-slope form that I have here. Okay, so suppose we have a line passing through the points 2, 6 and 4, 9. Find the equation of a line. What I want to do first is I want to find the equation of a line in point-slope form. To do that, I need to find the slope. So I'm going to use the difference in the y values, 9 minus 6, divided by the difference in the x values, 4 minus 2. And we have 3 halves. Our slope is 3 halves. Now look back here. Y minus y1 equals m times x minus x1. X and y, we're going to leave those in there as the unknown values of x and y, the variable values of x and y. M is our slope, which we just found to be 3 halves. And then x1, y1 is one of the two specific points that we have there. And it doesn't matter which of those 2 points you choose to use. So I'm going to use the 2, 6, x1, y1. So y minus y1, which is the 6, equals the slope 3 halves times x minus 2. And here is the equation of the line in slope-intercept form. If you prefer, you could use the other point, and instead of the 2, 6 being x1, y1, let the 4, 9 be x1, y1. In that case, you would have y minus 9, which is the y value, equals the slope of 3 halves times x minus 4. Either one of those equations is perfectly fine. Okay. In fact, I'm going to save that for later. I got to have thought there. We'll look back here later when we look at slope-intercept form of the equation of a line. To graph this line, 1, 2, 3, 4, 5, right? Maybe I should have had this pre-made. My points are 2, 6, always label the point, and 4, 9. Those are my 2 points, and here is my line graphed. Mr. Jensen, what's the y-intercept? What's the y-intercept? I don't know the y-intercept. I could figure it out later if I'd like. I believe it's going to be 3. And I could solve that if I need it. But do I need the y-intercept in order to graph the line? I don't. Again, I'll cover that in a moment. So let's do another one. A line passes through the points -2, 8 and 3, -5. To find the equation of the line in point-slope form, the first thing I need to do is find a slope. The slope is the second y value -5, minus the first y value 8, divided by the first value x, minus the first x value, which is -2. So I have -13 over 5. To find the slope of the line, or the equation of the line in point-slope form, I can use either the -2, 8 for x and y, x1, y1, or 3, -5. I'm going to just choose to use the first point. Y minus 8 equals the slope, -13 fifths, times x minus -2. Here's the equation of the line in point-slope form. If you chose to use the second point, again, you would have y minus -5 equals the slope of -13 fifths times x minus 3. Either one of those is fine. Again, to graph that line, -2, 1, 2, 3, 4, 5, 6, 7, 8. So -2, 8 is here. And 3, 1, 2, 3, 4, 5, -5 is here. So 3, -5. And then I can, draw that line. And there's the line that goes through those 2 points. It's a very crude graph, but you see the graph of the line that goes through those 2 points. Again, what's my x-intercept? What's my y-intercept? I'll worry about those when I need them. I don't necessarily need them yet. Let's take a quick look at slope-intercept form. This is something we're much more comfortable with. Y equals mx plus b. Okay, so a line passes through -2, 1, and 2, 3. So we're going to find our slope. That would be the second y value 3 minus the first y value 1, divided by the second x value 2 minus the first x value, which is -2. And I have 2/4 or 1/2. So the slope is 1/2. Here's what many of us are taught in an algebra class. This is what I used to teach in an algebra class. So if I go y equals mx plus b, I'm going to take that 1/2, my slope, substitute it in for the m. So y equals 1/2 x plus b. And now I have to pick one of my 2 x values. One of my 2 points. I think I want to pick the second point just because I have negatives in the first point. I'm going to put the -2 in for the x. The +2 in for the x. I'm going to plug the 3 in for the y. So when I do that, slide this up just a hair. 3 is equal to 1/2 times the x value 2 plus b. So we have 3 equals 1/2 times 2, which is 1, plus b, subtract the 1, and b equals 2. So then I'm going to take that 2, that value for b, and substitute that right back in here. So I have y equals my slope of 1/2 times x plus b. Whoops, I don't need that last parenthesis. This is something I think a lot of us are comfortable with. If I go to graph that line, what we're comfortable with is I have a y-intercept of 2, 0, 2, and a slope of 1/2. So I'm going to go up 1 over 2. Notice that's the point 2, 3. I'm going to go down 1 and over 2. Notice that that's the point negative 2, 1. These 2 points, those other 2 points I just graphed, this one and this one, those happen to be the 2 points that we were originally given in the problem. Okay? Why did I have to have the y-intercept? I don't know, because we're told we have to. So here's that line. Now, one thing I like about if I were to use, I'm trying to switch up my colors here, point slope form, I'm not trying to sell you on it, but I'm going to tell you why I like it a little bit better. Suppose instead of doing all of this substitution and substitution and substitution using y equals mx plus b, y minus 3, right? I'm going to use this point here for my x1 and y1, equals my slope of 1/2 times x minus 2. If I distribute the 1/2, so y minus 3 equals 1/2 x minus 1, I add 3 to both sides, y equals 1/2 x plus 2. I get the same values. Okay. The only difference is if I leave things using slope-intercept form, point-slope form, I may not always calculate the y-intercept. But what if it's not necessary? So what I'm going to do for this next problem, a line passes through the points 3, -5, and -2, 1. Rather than finding the equation of the line in slope-intercept form using the traditional method that we're often taught, I want to show you how to do that using point-slope form. So my slope is going to be 1 minus -5 over -2 minus 3. So I have 4 over -5. So y minus y1. Which point should I use? Let's use the first point. Y minus -5 equals -4/5 x minus 3. Now, I'm happy if I just want the equation of a line in point-slope form to stop here. But if I need to put it in slope-intercept form, I'm going to distribute the -4/5 to the x and to the -3. So I have y plus 5 equals -4/5 x plus 12/5. Now I'm going to subtract 5 from both sides. I choose on the left-hand side to subtract 5. And on the right-hand side, write that 5 as 25/5. So the 5 minus 5 cancels. Y equals -4/5 x minus 13/5. Okay. I have y equals mx plus b. I have my form that way. I suppose I could have done it the traditional way and I would have been fine. Okay. But graphing the line, I feel like I'm doing two things at once, which is hopefully not too confusing. I'm trying to show you, teach you how to find the equation of a line in point-slope form, reinforce how to find the equation of a line in slope-intercept form, but also help you understand when is which form better. If I want to graph this line from slope-intercept form, I need to find -13/5 on my y-axis, and that's going to be a little tough. If I know I have the point 3, -5, and I have the point -2, 1, okay, I can graph the line without having to deal with any issues. Of course, now we know my graph isn't perfect, but that should be 0, -13/5. fifths is that y-intercept. Is the y-intercept really magical? Okay. I will tell you for this course, write the equation of a line in standard form is not something I'm going to often have students do arbitrarily. However, we're often given an equation in standard form. Graph the line. Graph the line. So I want to think about graphing a line. If you graph a line from slope-intercept form, when I ask students what 2 points should you plot in order to graph the line, the answer I will often get is the y-intercept at another point. From point-slope form, what 2 points? Here's the answer. When you graph a line, you must graph 2 points. Which 2 points should you graph? I argue the easiest two. If I'm giving a line in point-slope form, okay? Let me see if I've got a blank page here. Sorry for this. If I just have, let's squeeze this in right here. Let's just say we have y minus 2 equals 3/2 x plus 5. If I was going to graph that line, that has a point -5, 2. 1, 2, 3, 4, 5, 1, 2. I would start at -5, 2. And from there, I would go up 3 and over 2. And I'm at the point -3, 5. Which 2 points do I use? I use the easiest 2 points. Slope-intercept form. Why do I want that y-intercept? Why does everybody say always start with the y-intercept? Simply because it's the easiest point to find. If you have the line, I'm going to squeeze this in here, y equals 2/3 x plus 6. If I'm going to make a table of values, x, y, the easiest point to plug in for x is 0. If x is 0, 2/3 times 0 is 0, plus 6 is 6. What's magical about the y-intercept is that it's often an easy point to find. So let's talk about graphing from standard form. If you're going to graph the line, how many points should you use? The answer to that is always 2. Which 2 points should you use? The answer to that question is always the easiest 2. What's different is which 2 are the easiest points. If I make a table of values for this point, x, y, the easiest value to plug in for x is 0. If x is 0, 3 times 0 is 0, so that goes away. Now we're going to solve this equation by dividing both sides by -2, and y will equal -6. So that gives me my y-intercept. We're college students, right? What's the next easy point to find? Well, if it's that easy to put a value in for x, when it's 0, let's put 0 in for y. If I put 0 in for y, 2 times 0 is 0, and this is now 0. So now I have the equation 3x equals 12. If I divide both sides by 3, I get x equals 4, and this gives me the x-intercept. I'm sorry for all of the erasing and rewriting, trying to keep this clean. So I have the y-intercept of 0, -6, and the x-intercept of 4, 0. Many people feel comfortable in that I have the y-intercept. I don't have it. I didn't find the y-intercept because it's magical. I found it because it's easy. The x-intercept was also just as easy, so I have the x-intercept. What I didn't find is the slope. If I needed to find the slope, I could solve this equation for y, or better yet, use these 2 points. You've got point 1 and point 2. Here's x1, y1, and x2, y2. And I could use those 2 points to find the slope. Okay. So what if I did this for this line over here to the right, x, y? If x is 0, 4y equals 15. So y is 15 fourths. If y is 0, 2x equals 15, where x is 15 halves. I have decimals, I have fractions. It's okay. What I will often do is, okay, 0, 15 fourths, 1, 2, 3, 4 is 16 fourths. So right about there is 0, 15 fourths. 15 halves is 7.5. So 1, 2, 3, 4, 5, 6, 7, 8. So right there is 15 halves, 0. And there's the line that goes through those two points. Okay, just a quick introduction there. A little bit more. Horizontal lines looks like this. They always have a slope of 0. Slope equals 0. And a line y equals k will have a y-intercept of 0k. So if this is, say, the point 0, 2, y equals 2 is the equation of that line. A vertical line is always going to look like this. It has no slope. There is no slope. Don't tell me what m equals. There is no slope. Notice it only goes through the x-axis. So if this is h0, the equation of that line is x equals h. Okay. Parallel lines are lines that have the same slope. Perpendicular lines, the product of their slopes is -1. m1 times m2 equals -1. Or we say m1 is -1 over m2. They're negative reciprocals of each other. Okay, so what I want to do real quick, and we'll finish this out, parallel to perpendicular lines. Let's suppose I have the equation y equals 3 halves x plus 5. Find the equation of the line parallel to the given line that goes through the point, oh, I don't want to use 2, I've used too much, that goes through the point 4, 7. If I use standard form, this is near impossible. It's a waste of your time. If you use point slope form, it's going to take you a while. I'm only going to show you using, if you use slope intercept, it's going to take you a while. I'm only going to show you this using point slope. The slope of this line is 3 halves. Therefore, the slope of a line parallel is also 3 halves. We know the slope, we know a point. Y minus 7 equals the slope 3 halves times x minus 4. Done. If you want to distribute the 3 halves and you want to change that to slope intercept form, you go right ahead, go look up above the way to do that. What if I want to, using the same thing, using all this information down here, except find the equation of a line perpendicular? Well, if the slope of the given line is 3 halves, the slope of the perpendicular is the negative reciprocal, negative 2/3. If we're going through the point 4, 7, now we have the slope at a point. If I use point slope form, y minus 7 equals negative 2/3 x minus 4, and I now have the equation of the line perpendicular to the given line. It's in point slope form, though, as opposed to slope intercept form. We get all jazzed about which form. It's not always important as to which form, as long as you use a valid form of the linear equation. All right, so that'll do it for us on section 2.1. There's a little bit more to this. I hope that you were in class with me. If not, I hope that this was helpful. And I'll see you back next time for section 2.2. Thank you.